Welcome pre-cal students. We're going to be looking at a different way to measure angles. Another way of just even thinking angles is not necessarily rays heading different directions, but by starting with two rays overlapping pointing in the same direction. In this case we'll say one blue and one green, and by rotating one of the rays while keeping the other stationary. So if we keep this blue one stationary and we rotate this green one upwards or downwards, we can create an angle, almost like the hands on a clock. That's another way of creating a ray. Creating an angle. When you take angles and you form them by rotating them clockwise, the angles are negative. When angles formed by rotating them counterclockwise, those are considered positive. So if we have our stationary side, we rotate it down this way, we could say that's something like negative 30 degrees. The negative purely is just indicating a direction. Just like if I were to take this and I were to rotate it up this way, we would say that's, I don't know, it looks to be about positive 50 degrees. The negative, the positive, just indicates which way you're rotating your one ray in order to reach the other one. These rays have different meanings and special names. The one that says stationary is called the initial side, and the one that we rotate to is called the terminal side. Terminal meaning ending, obviously. Next, angles which share the same initial and terminal sides are what we call co, meaning same terminal. One example of these would be something like to rotate downwards negative 30 degrees would be the same thing as rotating in a positive direction 330 degrees. Either way, to rotate down negative 30, you would end up with this red ray. To rotate all the way around 330 degrees, you'd end up with the green ray. They'd all be at the same place. This next question is asking us to find two positive and two negative coterminal degrees with 37. So if we say here's our angle, which is 37 degrees, you've already rotated 37. So another way, and there's any multiples of ways, what we could do is start at the 37 degrees and rotate all the way around, not only to our initial side, but all the way back to our terminal side. In other words, if we go a full circle around this 37 degrees, we'll come up with another terminal side. So if we start at 37, what we're going to be adding is a full circle's worth of degrees, which are 360, to give us 397 degrees. Now, what we could do is then go again for another circle, go all the way around. So we're going to leave off with 397, but we're going to tack on another 360. When we do that, we come up with 757 degrees. Now, looking at the negatives, though, rather than rotating counterclockwise, we're going to rotate back clockwise, which means instead of going 37 plus 360, we're going to go 37 minus 360, yielding us negative 323 degrees. We can take negative 323 degrees and rotate it back another full circle, which would give us negative 683 degrees. Now, if you notice, a lot of times my initial side is heading directly to the right. That's because what we say is an angle is in standard position when the vertex is at the origin and the initial side is on the positive x-axis. In other words, my angle is going to start right here at the origin. My initial side comes out to the positive x-axis, and it doesn't matter where my terminal side is. Now, this is the same idea. A central angle is going to be the same thing, except for what we're going to add to it, to the angle in standard position, is a circle centered at the origin. So now this is now what we call the central angle, rotating from the side. Okay. There's another way of measuring degree or angles. All you've been introduced to so far is that an angle gets measured by a degree. An angle gets measured by a degree. Well, just like a length could get measured in feet or in centimeters, there's another way that measures angles. It's called a radian. A radian is another way of measuring angles. A radian is what happens when you start with a circle and you say, here's its radius. This radius, we'll call it r. The radian, an angle with a degree that's equal to 1 radian, is the amount of rotation it takes to travel that same distance r along the circle's circumference. When the circle's circumference, when the arc that's created by rotation of 1 radian, when that arc is equal to its radius, you've rotated 1 radian. There's a lot of different ways, and this will probably get further explained differently by each teacher. But again, the biggest thing is that this distance, the circle's radius, is equal to the amount of distance traveled around the circle. You rotated 1 radian. Now, given an angle measure in radians, we can figure out this formula, this arc length, pretty quick. All it's going to equal is the arc length S will equal whatever the radius is times theta. Now, the only difference is theta, angle measure, has to be in radians. It can't be in degrees. You need to work in radians. This has some really cool math, and we're going to keep this in our back pocket and kind of show where this comes from and show relationships, but it's going to help us out with something later too. Another way, given an angle measure in radians, once again, the formula for the area of a sector of a circle. So, if I were to draw a circle, if I were to draw an angle, a central angle inside that, I can figure out the area of that circle with the expression area equals 1/2 pi the radius squared times the angle, in this case theta. Hopefully both of these kind of look familiar, maybe are ringing a bell, maybe you can see some connections, but we're going to show them in a little bit. Practically speaking, let's just show you how you can kind of plug and chug with these. What is the arc length and the area of a sector created by a central angle of 2.5 radians and a radius of 5 inches? Well, the arc length will equal the radius, 5 inches, times 2.5 radians. That equals 12.5. The area will equal 1/2 inches. Another way, by the way, rad is the abbreviation for radians, kind of like a little circle is for degrees. And sometimes when you see this inputted, it'll say 5, let's say 5 inches squared times, you'll just see 2.5. If it's talking about an angle, and it's talking about an angle measure, and there's no units associated with it, it means that it's giving it to you in radians. Both of those are acceptable notations. 1/2 pi times 5 squared times 2.5 ends up equaling 31.25 pi. Again, we're going to keep these in the back of our minds as we go on to explain a little bit more in detail what's happening with these radians.